Okay, so for assignment 6, I kind of gave you the idea here. So again, in this assignment, you want to find, given a tree, whether it is height balanced or not. And again, what is this height balance property? For each internal node, we have to find the height of its left subtree, which is basically the height of its left child, and the height of the right subtree, which is the height of its right child. And the difference between the two height values of the left child and right child, the absolute difference, should be less than or equal to 1 for that internal node should be to be considered as height balanced. So if any internal for any internal node, if the absolute difference between the height of the left child and the right child is greater than 1, then we say that internal node is not height balanced. And even if one internal node is not height balanced, the whole binary tree is not height balanced. So I have given you a startup code where after setting up the binary tree, you can call the getTreeHeight function on the binary tree node object. And the getTreeHeight function basically calls the getNodeHeight and passes the root node ID 0 as the argument. And we saw in class this is a recursive function, so in order to find the height of the root node, you should know the height of its two child nodes. Think about this example that we went through. You see the height of the root node is 1 plus the maximum of the height of its two child nodes, and that's the formula. Height of a node is 1 plus the maximum of the height of its two child nodes. So you need to know the height of node 1 and height of node 2. Again, you will be finding this in a recursive fashion. So height of node 1 is 1 plus the maximum of height of node 3 and the height of the missing right child, which is negative 1. And you find height of node 3 again in recursive fashion. So if you see the code get node height, you are first finding the left child ID and right child ID for the particular node ID for which you want to find the height, and finding the height of the left child and finding the height of the right child. So even in the lecture, in the class, I mentioned that you are finding the height of the left child and right child of a node, so you could store it somewhere so that later if you need to use this height values, you don't have to recompute it. Okay. So that's the logic I gave you here. You can add a member variable like an array to keep track of the height of the individual nodes of the binary tree. So what you could do is in the binary tree class, you could add member variable, say a pointer that's pointing to the array of the height values. So it could be an integer pointer, and you create that pointer here in the constructor of the binary tree. Create the array. Create the array in the constructor of the binary tree and make the pointer to store the address of the array. Okay. So similar to how you created the array of BT nodes here and make the array of BT nodes to store the address of that array, you can create an array of integers and make the integer pointer for the height to store the address of that array. That's going to be a simple process. And then once you have the array that can store the height values of the nodes, then you can set the height value of the left child ID to be whatever you find as the height of left child, and the height of the right child ID to be the height of whatever you find as the right child. Then in this function, to check if the binary tree is height balanced or not, you have to just simply then run a for loop that goes through each node, and if a node is not a leaf node, it's an internal node, then get the height values of its left child and right child using that array. You don't have to recompute the height values, and find the absolute difference between the height values of the left child ID and right child ID. If it is less than or equal to 1, keep continuing to the next internal node and so on. If for any internal node, if the difference in the height values of the two child nodes is greater than 1, you can return false from this function. If you have gone through the check for all the internal nodes and all internal nodes are height balanced, then you can return true from this function. Okay, I hope this is useful to do the assignment.